Good morning. So in the last class we have already discussed about the course objective 3, that is energy efficient performance in lighting systems, in the aspects of energy efficient aspects in lighting systems. In that we have already discussed the basic terminologies involved in lightings and what are all the lamps available, what are all the lamp working principles, all those things we have discussed. And also we have discussed this current slide, effect of voltage on lamp efficiency. This also we already discussed. And one thing I need to highlight here, this is the characteristics of an incandescent lamp, that is performance characteristics of an incandescent lamp. The previous one is performance curves of fluorescent lamp. So in both characteristics, when you reduce a slight voltage, you may get higher efficiency. That is the main thing you need to observe here. On the 10% of lower voltages, your efficiency is high, right? And also here, when you have reduced some amount of voltage, your life is increasing. That is on the incandescent lamp, where your efficiency decreases on this period, and when it goes high, your efficiency is saturating, this one, so somewhat increasing. So this is the difference you need to observe here. That's why we are promoting the usage of fluorescent lamp in place of incandescent lamps. Presently we are promoting to the CFL, that we will see later, right? And now, effect of voltage on lamps. So here that is the summary of those two slides. Within the normal range of supply voltage variation, the light output will change about 3.52% for 1% change in voltage. The effect of voltage on life is much more pronounced. That is 5% over voltage will roughly half of the lamp is reduced, whereas 5% of under voltage will approximately increase the life to the double life. If it is found that lamps are consistently failing prematurely, that is before the lifetime, then the first thing to investigate is the agreement between the voltage marked on the lamp and the actual voltage what we are feeding to the bulb. So that you need to check. In certain cases, it might seem attractive to operate 240 volt lamps on 230 volt circuit to secure the increased lamp life, until it realized that doing so the light output will fall considerably more than the corresponding reduction in electricity consumption. So this, you just go through it. And next thing is, what are the possible energy efficient replacements we can suggest? So in the domestic sector, general lighting services, that is nothing but your incandescent lamps. Incandescent lamps will be known as general lighting services. They can be replaced with CFL, compact fluorescent lamps. And when you see the reduction in the watts usage, for a 100 watts bulb, how much illumination this can illuminate, that is your general lighting system can illuminate, the same can be achieved here with 25 watts of CFL lamp. That means you are saving 75 watts, 75% of saving. In the industry sector, the same thing is feasible. And also you can go for general lighting, you can go for blended lightings and tube lights, and this is the thin tube lights. This is a conventional tube lights, and this tube light is nothing but 36 watts thin tube light. And here it's a high pressure mercury vapor lamp, and this can be replaced by high pressure sodium vapor lamps. So on these cases you can see the power savings. So why this is important is, whenever you can see these sort of lightings, you can think that you can replace with this sort of lamps or bulbs so that you can reduce this much amount of energy consumption as well as the cost savings. Now, you keenly observe this case study in a textile mill. To minimize the lighting power consumption, that means lighting load, to minimize the lighting load, conventional 9 watts loss tube light ballast, 9 watts tube light ballast, which has a loss of 9 watts, right? With the replaced with the terminology, the tube light ballast, which has 9 watts loss, replaced with a new one of electronic ballast, which has 2 watts of ballast loss. So in the earlier already fitted on the 9 watts ballast loss, and the proposed new one has 2 watts of ballast loss. That is the thing you need to observe here. And 40 watts tube lights are replaced with 36 watts tube lights, which is in the number of 750 numbers of a single lamp tube light fitting. The cost of electronic ballast and 36 watts tube lights are rupees 225 and rupees 45 per unit respectively. Calculate the power and energy saving potential if the mill operates for 800 hours, 8,000 hours in a year. Also calculate the investment required and payback period for the above energy conservation proposals when the energy cost is rupees 4.5 per kilowatt hour. These are the data you can retrieve from the questions. Conventional tube light watts is 40 watts. Conventional tube light ballast loss is 9 watts. You are going to replace with a new tube light which has a watts of 36. The new ballast is 2 watts. So the ballast is nothing but in the tube light fittings you can see a square box, rectangular box like arrangement. Recently, which is an electronic one, conventionally which is made up of coils. The purpose of the ballast is to start the tube light functioning initially for a short fractional time duration. The ballast will increase the low voltage to high voltage, right? So in that time electrons are bombarded from one terminal to the other terminal. By that way the tube light starts igniting. So the ballast works only on the starting duration, and later on continuously there is no boost up value of voltage, but it consumes some amount of power, and that is what your 9 watts and that is what the 2 watts, right? In ideal condition this consumes 2 watts. Number of again we will come for the data. Number of tube light fittings replaced is 750. The cost of electronic ballast, all these things we have rewritten here, and you need to calculate these things. You see here, power loss involved in conventional tube light system. Total number of tube light is 750. The bulb consumes 4 watts extra compared to this one, that is your new system. That means new system consumes only 36 and this consumes 40. That means 4 watts here it is a loss, plus the ballast loss is 9 watts, right? And totally the watts loss is 9750 watts loss through the conventional tube light system. So if you calculate the energy for this cost, energy means this much amount of watts works for this many hours, that is 8,000 hours per year, and per unit cost, when you divide by 1000, which becomes per unit, kilowatt watts divided by 1000 will give watts divided by 1000 will give the kilowatt, multiplied by hours which give the kilowatt hours. So now 4.5 rupees per kilowatt hour is the tariff. When you multiply these two things, this much amount you need to spend towards the loss, right? And here you see the other combination. Power loss involved in the new tube light system, 36 watts. Since it's 36, there is no better option, so loss is 0 here, and 2 watts via the electronic ballast, which is 1500 watts. The same way if you calculate, which gives 54,000 rupees as a loss. So the difference you can calculate. The energy cost saving is this much. Difference of earlier one with the new one will give to 2,97,000. So what is the investment you need to spend? Per ballast you need to spend 225 rupees. Per tube light you need to spend 45, and for a 750 numbers totally 2,02,500 rupees. So now you can calculate the payback period. Initial investment, this one, divided by annual saving, this one. So initial investment is 2,02,500 and divided by 2,97,000 rupees into 12 per month. So this per month basis, when this is for yearly period, and you are converting for the months, payback period in terms of months, and this is 8.18 months. So now power saving is this much watts, energy saving is this much watts per year, and cost saving is this much, and your payback period is 8.18 months. That means around 9 months time period you will get back this amount of money, and later on you will be benefited with this much amount of cost every year, right? So this is what the understanding you can get out of this case studies. And then another option you just go through is your incandescent lamp. General lighting system is nothing but incandescent lamp with 200 watts can be replaced with, what is this, ML? Mercury lamps, and where you will get 7% of efficient savings. And similarly you can see the various ranges, what is the savings. And tube light of 40 watts can be replaced with 36 watts, where you get 6% saving. So this is a general table to easily find out the replacement options, right? So you just go through this, and these are the remaining important things. Energy saving opportunities in lighting systems. First thing is, as far as possible, try to use the natural day lighting. And here the highlight is, most of our Vastu tips will promote the natural lighting in houses that also fit for any industries, right? And another thing is de-lamping to reduce excess lighting. So excess lighting means, suppose in a room you require 200 lux, means unknowingly you may produce 400 lux with extra lightings that can be reduced, right? And task lighting, this is based on the requirement of the particular task, you need to provide the lighting. And next thing is selection of high efficiency lamps and illuminaries. Illuminary is nothing but the cover arrangement for the lights, which will have a reflection effects, and if you have a huge reflection effects you will produce huge amount of light, and that also you need to select accordingly with a high efficient. And another thing is reduction of lighting feeder voltage. Suppose in your houses lighting load alone can be connected in a single line, means that line voltage can be minimized, which may not be feasible in houses, but industry it is feasible. The lighting feeder voltage alone can be minimized to some 10% or something, and wherever it is possible you need to use the electronic ballast, and you need to go for the lighting controllers that we will discuss in the next video, and lighting maintenances. And these are the lighting controls. So occupancy sensors, use of occupancy sensors, that means in a classroom no one is there, means automatically these sensors will, IR and UV and microwave sensors will switch off the appliances. So that is the purpose of appliances sensor. Hope the remaining thing we will continue in the another series of lectures. Thank you for watching.